Hello, my name is David, and I'll be going over the limit of x as approaches 0 from the right of this function. Okay, so the first thing we want to do, um, let's plug in 0. If we plug in 0, we're going to have 1 right here. This will turn into 1, and then it will be 1/3 plus this will turn into a 1, and then this would be at 2/3. And now we get to add them together, and there'll be a 6, 3 plus 4. That should be 7, 6 over 1 over 0. So that means 1 something over infinity, which is an indeterminate form. So because we have a value over with the power of infinity, that means it's indeterminate. We don't know what it is. So that means we can use L'Hopital's rule. So that means we need to turn this limit into a fraction. The best way we can do that is by using a natural logarithm. So if we say that y equals the limit of 1/3 times 3x plus 2/3 times 2x 1 over x, and then if we take the natural logarithm of both sides, we say that the ln of y is equal to the limit as x approaches 0, and then this will be an ln. That means this fraction right here can't go to the front. Those are just properties of logarithms. That means this x will come down here, and then this will be the ln of 3x over 3 plus 2 times 2x over 3. Okay, so now this is into L'Hopital's. But let's see if we can maybe solve it. So let's plug in 0. So we're gonna have 0 in denominator, and then if we do 1 over this one, will be 1/3 plus 0. 2 of 0 is 1, so 2/3. And we can see that would be 3 over 3, and that would be the ln of 0. And if we remember, there's an asymptote at ln of 0, so it doesn't exist though. So we can use L'Hopital's, and we can derive the numerator and the denominator. So let's do that right now. So we just, if this is the same, the limit as x approaches 0 of the top. So the top would be 3 x over 3 plus 2 times 2x over 3, and then the top would be 1/3 times 3x times the ln of 3 plus 2/3 times 2x ln of 2. Okay, so and then the denominator will just become a 1, so we don't really have to do much there. So now let's try to make this a little neater. So we can see that we can combine this. I'm going to scroll down. So I'm just going to take this right here. I'm going to rewrite it better. So it would be more. It's the ln of 3 plus 2 over 3 times 2x ln of 2. Okay, so right here, let's combine them together. So this will be, I'm gonna just do the numerator first. So it'll be 3x ln of 3 over 3 plus 2 times 2x ln of 2 over 3. And then if we add them together, that would be 3 over 3x ln of 3 plus 2 times x to the x times the ln of 2. And now we get to simplify the denominator, and that will just be 3 over 3x plus 2 times 2x. And let's don't forget the limit as x approaches 0 from the right. Okay, so we can simplify this even more. We want to simplify as much as we can because we want to see if we can use L'Hopital's or if this is solvable. So that means if we take this, the numerator, and divide it by this, I'm just gonna do it right here. I'm gonna just bring this up top. You can see that the 3 would go up here, and then the 3x plus 2 times 2x, and then we can see that these two cross out, and that means we're gonna be left with the limit as x approaches 0 from the right would be 3x ln of 3 plus 2 times 2x ln of 2. All of this will be over 3x plus 2 times 2x. Okay, so now this is the most simplified we can get it. So now let's see what happens when we plug a 0. So this will become a 1, and then this will become a 2, so that will become a 3, and then this will become, oops, sorry, that was supposed to be a 3. Yeah, so this will become the ln of 3. This will become plus 2 times the ln of 2. And then we can see if we do this correctly, the denominator will come 3, and then this exponent can go up here, and this will become a 4, and then is the ln of 3 plus the ln of 4, and that means we can simplify this and say that this is going to be the ln of 12. Okay, so now that we have the ln of 12, that would be the value of this limit. But if we remember, we took the ln of the y, so ln of y equals to the limit, and we figure out that the limit is the ln of 12 over 3. That means we just need to solve for y. If we erase it by the e of both sides, this would be alone, and then this would be e to the ln of 3 over 12. That means this will go away, the ln will go away, and so that means this would be, oh, and then you see this as a fraction. This is technically 1/3 ln over 12. That means that with the properties of logarithms, this 1/3 can go to the exponent. So that means this is technically the same as the ln of the cube of 12. Okay, so now because we raise this to the e, that means the ln can go away, and that means our answer will be cube of 12. And that will be the answer. Okay, and that's it.